Okay, good morning, everyone. Looks like we've got a few people on the call, so we might as well get started. Thanks again for joining. My name's Pete Murphy, and I'll be moderating today's webinar titled Why Automation is Key to an ISV's Success, which will be presented by David Wright, Channel Solutions Engineer at HashiCorp, and Adrian DeLuca, Head of Partner Solution Architecture at AWS. So today, Adrian and Dave are going to talk about some of the typical challenges you can face when building SaaS applications in the cloud and how to solve those problems with using modern day tools designed for the cloud. I'd like to note that this session is being recorded and a recording will be made available within a day or two, and I'll email it out to everyone after this event. So today's webinar will last for about the presentation and demo should go for about 45 minutes, and we'll have hopefully 10 to 15 minutes at the end for a Q&A. But in the meantime, feel free to submit any questions you have in the chat at the bottom of your screen there, and we'll get to them at the end of the call. So with that, let's go ahead and get started. Over to you, Adrian.
Hey, thanks, Peter, and thanks everybody for joining today. I have the good fortune of spending a lot of time with software builders and ISVs now right around the world to actually understand what are the sorts of things that they're thinking about as they're building new cloud native products, as they're bringing their products to a global market, but also how they're getting a lot more efficient in the way that they're actually delivering what customers want. And now being here in Seattle, gives me a pretty good appreciation for how AWS is also looking at the next couple of years of helping these ISVs along this journey. But I wanted to start by sharing with you some interesting statistics that was done based on some market research that we did a couple of years ago. It's amazing to think that we're now looking at a marketplace for software as a service over $100 billion. This is a little bit dated now, but the market opportunity for SaaS or for software builders has really increased massively. And so has a lot of the challenges that have been coming out. What we found is that 89% of ISVs are very much moving towards a software as a service delivery model as their key motivator to refactor their applications or modernize their applications. And they also noted that 80% of them have the ability or noted that the ability to rapidly respond to those changes in customer demand was actually a blocker in being able to deliver those sorts of features. We've got new native cloud native builders that are building products from the ground up. We've got legacy or existing traditional products that are being modernized for the cloud. And we've also got products that are just being re-platformed for multiple clouds. Yet, a lot of them are citing being able to deliver that capability is going to be, challenged if we don't add some automation.
31 minutes left in the book.
And finally, I'm sorry, I got to turn Alexa off. She's talking to me right now.
How AWS is that?
very, very AWS indeed. And finally, when we started to look at also, what are the sorts of blockers to actually develop to this new mode of operation, 77% of ISVs associated that the cost of building, the on-premises versions of their product, was also a massive blocker to being able to really develop modern software architectures that really meted the needs of modern customers today. So if we look at the next slide here, this starts to give you an idea of what some of the vectors in the challenges that exist for a lot of these ISVs across the different architectural postures and software products that are being built. If you look at the traditional single tenant products, being able to scale provides some medium-term challenges, and the application development isn't very high. But one of the biggest blockers is just taking a single tenant product and wrapping it around some managed services. Really turns out to be a very high cost per tenant architecture design. When we start to look at organizations that have started to introduce some multi-tenanted features, things like being able to have, say, a frictionless onboarding experience, or being able to do some shared pooling microservices, but still fundamentally using a single database per tenant. Some of the higher cost areas are really in being able to manage that data environment and being able to scale each one of those tenants independently. Similarly, when we actually look at a full multi-tenanted or multi-tenanted highly distributed application, we start to see a lot of those factors really reduce because of the high levels of automation, observability, and monitoring that is typically associated with it. So, these are typically journeys that we see a lot of ISVs actually going on. There's not that many ISVs that I've seen that have been able to go from very kind of traditional archaic type of software applications and move straight into multi-tenancy, at least not with a lot of pain. But it's the learnings along the way that have really taught a lot of these ISVs how to do it well. So think of these as journeys and building up capabilities. But one of the core principles that we see quite consistently is adding automation in the various levels of architectural design, deployment, measuring and monitoring, metering, and all the other different types of software patterns that we see are needed to be able to deliver something at such a global scale. So if automation is the key to unlocking that scale, what are some of the principles that Dave's going to cover today that both AWS and Hashicorp deliver? First of all, having a continuous integration, continuous delivery pipeline that is highly automated means that you can really deal with the velocity and changes that go on in a lot of software development teams. Also, doing the testing, whether it's validation, regression testing, or new feature release testing, being able to do that at scale, particularly now as we're starting to get into very highly tailored, personalized experiences, particularly in software as a service, becomes really important. It's a massive, massive cost for a lot of organizations to maintain all these different test and development suites. Of course, provisioning, especially when we start to talk about not just provisioning for a single client or a number of users inside of a client, but think of all the different provisioning postures that are required for global clients, particularly for clients that may not have a cloud region in place or close by, or have things like GDPR requirements. Being able to provision for latency, provision for proximity, and being able to do that level of deployment at a pace that keeps up with all the different features and functions that are being introduced becomes really important. And finally, delivery to the customers. Investing in the tooling is something that you just can't do without. Many will, I've seen as an anti-pattern will say, hey, we'll come and do all this automation later. Let's just get the product out the door. But of course, it becomes a lot more expensive and typically gets put on the back burner when you do implement those things later down the track when you are seeing that provision and scale. So these are just some of the 4 areas that I ask all of my ISV customers to really consider as they're scaling and growing into the new world of software as a service. So with that, let me hand over to Dave, who's going to run you through just some of the things that AWS and HashiCorp are delivering together.
Thanks, Adrian. I'm going to do this a little bit backwards. So hopefully you can see that screen. Can we? What we're going to do is, I thought I'd just show you one of our Learn portals. Our Learn portal is basically where we go to share all of our information, and we have a really up-to-date and really keep on top of what's new. this is a really simple element to provision an EKS cluster. So it walks you through the steps. Obviously, you need an AWS account, but it will basically build out this environment for you, which, as we know, can be quite complex. So let's just clone the repo. We'll 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 change into there. Now, the first part that we need to do is initialize our environment. And what this does is pull down all of the modules that are required for us to talk to the AWS APIs. And those modules are actually written in conjunction with AWS. So there's a lot of effort put into joint engineering, a lot of effort in putting into making sure that we have day zero support for features. So after Innovate last year, we actually had support off the bat at day zero support for 7 of the new features that came out as we'd worked in conjunction with it. And so once this is downloaded, internet's a bit slow today, a bit wet springs breaking. There we go. What we will do is apply this. Now, what this does in the background is, and I'll talk about these concepts a little bit more, but this is doing a Terraform apply. And what part of the apply is it will actually create a plan of what the outcome is going to be. So here you can see us pulling information back from the APIs to understand what's happening in the background, what's already been created, and what the state is. And once that's been created, it will create this plan. And now this plan is all of the objects that actually will be created. And you can see here there are 52 new objects that will be created. Hence why I'm doing this first. So let's kick this off. And then we will go back as that starts creating to talk about some of the other elements. And we'll go back to that to have a look at what's been done. Hopefully it will work. Demo gods. So one of the important things that Terraform really kind of takes in and is a concept that we work around is the concept of a workflow. So how is that different from, for example, the conversations around workloads and moving this workload? Well, the big difference from our thinking is that with workflows, you're very much looking at what the overall outcome is. So this could be, how do I deploy that single tenancy? How do I deploy the multi-tenancy component? Or how do I update an individual component within that architecture? And so the workflow is that the underlying outcome. But within that, obviously, there are then elements that can be tied together using the concept of workspaces. And those workspaces then allow you to deliver individual component parts or functions that deliver a networking or a security component. And when they incorporate that with leveraging Terraform Cloud or Terraform Enterprise, those products also have Sentinel built into them. And Sentinel is our security as code stance. And that means that before you actually, between that plan and that apply point, you can actually have security applied to the plan before it is actually able to deploy. So if someone tries to deploy out of hours, you could stop that. If someone tries to deploy any security group, you could stop that. You can put in requirements around image sizes and context sizes so that your test team can never deploy an M1 large because on the weekend they want to do gaming with it. There's those kind of things and those elements. And so how that ties together is once we get into that automation that Adrian talked about, we're looking at how do you create a pipeline. Those pipelines are tied into specific modules. These modules then use that dry methodology so that don't repeat yourself. And what that means is each one of these modules can be built to create a function. So networking, storage, or even part of the application elements. And now you tie those using version control into your workspace. Your workspace then can call different elements as you run your workflow. So as you're moving through from trying to deliver your outcome, you have these different modules that will allow you to reuse your code, write the code once, test it, validate it, put it into your pipelining where you trust it, and build a trust model around all of these individual components that allows you to actually deploy your overarching workflow. Now, how do I get started with these these modules? Well, there's over 700 different modules available in the public registry, so registry.terraform.io. There are a whole bunch of great stuff there around creating, Postgres Aurora or Lambda functions, or a whole different stack of different modules that you can pull out of the AWS platform suite. And that allows you to kind of experiment and get started. However, obviously, you may want to create some golden images of that or some golden standards. You may want to tie in specific tagging, which is obviously best practices as you start to get into that multi-tenancy component. You may need to, you may want to tie in specific IP addressing or security elements that you tie in. And leveraging Terraform Cloud or Terraform Enterprise, you can pull those public modules into your private registry and create a private point of reference that can then be used in your code sets as that repeatable element. So now you're leveraging the power of the community to create your own private elements. And all of these bits fit together to create these functional workspaces. And the thinking around the micro infrastructure, which allows you to focus a workspace that deploys a workload, and that workload then fits into your overarching workflow. Now, the good thing around all of these elements as well, particularly when you start to leverage the Enterprise Edition, is we actually start to manage your state as well. And what happens with that is, not only does it mean that we can control variables and sensitive information. So once that goes into Terraform Enterprise, we actually leverage Vault, one of our other products, to be able to obfuscate and securely control that. So if you wanted to share workspaces across different resources, but didn't want them to be able to see the AWS or secret keys or elements that they shouldn't, you can actually do that and make sure that the environment variables are kept secure using that backend platform. But why is state important? Well, fundamentally, we know that building and tracking and then day two operations are very different things. And when you get into this element of we want to build quickly and effectively and try and reduce, some of those operational costs, how do we keep track of that? Well, obviously, when Terraform's used, it will manage that state for you. And so you know what that declared state looks like and what's actually been defined. The other advantage of that, of course, is that you can now use Terraform as a day two operational tool as well. So it's not just about using it to deploy and build, it's also using it to manage and control. So once your infrastructure has actually been deployed, you can now actually go back, do updates, add smooth changes. You can take infrastructure out, you can put infrastructure back in, all using a single tool set. And that tooling allows you then that flexibility to integrate and build trust into pipeline, into a tested validation. So you can integrate the Terraform output into a testing tool. That falls then into a delivery mechanism, and it has webhooks and automated processes to kick that off. And then you get your automated delivery. And from a customer experience, what that means is that when you work with an onboarding, you can tie this into AWS Marketplace, you could tie this into your commercial front end, and now from a customer experience, they have an automated journey that allows them to stand up an environment and start interacting with your product a lot faster. All of these things are then tied together to deliver that outcome. So let's just take a quick look and see if this demo has built. Oh no, hasn't gone through. All right, we'll just go, we'll keep going, we'll go back to it. So let's just move on and talk about Vault and the Vault element of where it fits in. So Vault has this concept of secrets management. And why is secrets management important? Well, secrets management fundamentally is a key value pair that you don't want to share with someone. And whether that's something as complex as a dynamic secret, which we'll talk about a little bit more, or something as simple as a key value, a simple username and password. Controlling those elements, particularly as you start to move to the public cloud from having built your infrastructure in an environment that you have very much and tight control over, how do you now keep a single source of truth? How do you have a central repository that you know that you can lock down? How do you have a single place that you can audit? And more importantly, how do you have a place where that communicates quite easily across all of these boundaries? And this is where Vault actually fits in. So Vault is built around an API. It was initially built, or solely, it's initially built as a product to service API calls. And so this gives it a really important advantage when looking at products similar to this. And Gartner put us as top of the quadrant because of this, because it allows things to massively scale. Because it was built for machine-to-machine communication, that means that it fundamentally knows that it has to work fast. Terraform, Vault Enterprise, also allows for multi-tenanted through namespaces. So you can divide up this namespace division and start to get different multi-tenancy availability across it. And it all works in using these three kind of key concepts. So a client will need to authenticate using a mechanism of trust. Once it has that trust, we provide a token, and that token allows the client or application to talk through Vault to then talk to our secrets back engine. And the secrets engines are plug-in mechanisms that are built to interact with different elements. Now, whether that's a database element, whether that's a transit encryption element, or whether it's actually our advanced data protection backend, which does tokenization. So how does this fit into the ISV journey? So, some things to think about is, where are your passwords when you're looking at building in these kind of different models? Have you got a single password that is then shared across those databases? How is that password and element shared when you need to stand up a new tenancy in one of those? Is it manually hard coded in? Is it written on the back of a sticky note that gets shared around? Is it in email? All of these things obviously open up your attack profile and particularly if they start getting accidentally submitted into version control, which then may bleed into a public domain. And how do you write for an API? Can your secrets retrieval be easily done using the API as a first-class citizen? Can you actually get access to it quickly and easily? Will the API scale? And how many of them do you have? And how complex are they? Do you put rotation around it? How long do they live? All of these things are important elements that we know that you don't want to be, that you have to manage, and you don't want to be that SaaS vendor that is then seen in the news where these simple things and industry common practice has been overlooked because of, as Adrian was talking about, we needed to get you going, we need to get to the cloud, we need to just get this built. And so all of these things kind of hook together. And this is our wall of credit. But I think a really important name to call out is the Adobe use case. Adobe has got like over 130 different teams leveraging Vault across their environment. And they stood up at our 2019, which seems a long time ago now, the Hashicorp digital conference, and talked about 100 trillion transactions that Vault had been managing. There's hundreds of millions of transactions a day that they actually put through it. That type of scale is hard to achieve at the best of times. And so being able to do that at scale with a security product is a real power of Vault. And then when you start to look at other use cases, how are you then integrating and putting in managing your customers' data? How are you managing that end-to-end security? And again, back to that point around GDPR or or not being the name in the news, you have to have a strategy around thinking around how to do this. And so again, leveraging Vault to be able to use its transit engine, where it doesn't actually hold the data, but it will actually encrypt on the fly as you move through the data to be stored on those backend databases. So in that case, we can actually have a quick look at the demo, and here we go. So that Terraform was built out. It built those 50 to 52 objects, and we've actually even leveraged and built out a config map that you could use. Now, because we've used a local execution, we can actually get this to execute locally on my machine and then use this for associating to our cluster. So back to the Vault component. This is a simple app that we just use, and hopefully if we go database view, yes, still working. If we add a record here, I'll just add me in. The American Social Security numbers format, but anyway. And they considerably underpay me here. So there we go. So from an application perspective, you can see, the application can see and interact with this. But from a database perspective, Vault has now encrypted that mechanism, and so from a database view, the records list they pulled out are completely encrypted. So even if you do compromise, even if your database was compromised, the keys they pull out are all the data files are encrypted. I mean, that's a massive reduction in your attack profile. Also, one of the interesting things is you'll see here that we're using what's called a dynamic secret. So this interaction is Vault dynamically creating the username and password for the application to log into the database. So you need to actually talk to Vault, get that trust token, come back. It will give you the username and password. The app then goes to the database and uses that dynamic secret. This has a time to live associated with it. And that means that you can rotate that password on a one-time basis if you really wanted to. I mean, given performance and scale, you probably do it maybe hourly, or if it's really, really heavily hitting the application, maybe daily. And this same concept about being able to rotate using that time to live applies to the encryption mechanisms. So now you have a single API that allows you to make a cert call, get that cert back, and rotate it at a very easy time period. So you can set a time to live around that. And so I can name and shame myself where you do I'm going to create a 10-year back-end certificate because I don't want this thing ever to time out and it to fall over. You can now do this automatically and rotate it daily, monthly, whatever the time is. And so you've now subsequently reduced your attack profile and created a lot stronger value proposition for not being that ISV that lands up in the news.
And Dave, I think it may be worthwhile talking here to all the builders out there is, first of all, Vault does use the AWS Identity Access Management, so you get the benefits of that fine-grained control. And all the secrets are stored in the AWS Key Management Service, KMS. So, whether it's the dynamic database credentials that you talked about, or whether, you're running large farms of EC2 instances and need to maintain, the right key or authentication mechanisms across your different auto-scaling groups, you've got this really tight-knit experience.
Yes, and it's a couple of good points there to expand on as well. Is so with the auto unseal and KMS, when Vault, because Vault is built around a crypto barrier, you actually have to unseal it. So if for any reason that you ever did feel that it was compromised, you have a break glass facility to shut that down. That unseal process writes those keys back into KMS so it can automatically stand up. So from an operational perspective, we've made it as simple as possible to make sure that when you build in the cloud, you now have a mechanism that's really easy. Another tool, another secrets engine on the back end is obviously SSH keys. So now as you're standing up those SSH keys across potentially different regions, you can have a single point of control that where all of your SSH keys are being pulled from automatically. So it eases that burden of operation again. And you can tie that into then into your Terraform. So you have a stand up, you can pull a key, you've got everything automated in a very easy process. And this all speaks to tying the HashiCorp toolset together to solve those challenges of working with the cloud. And some of those challenges that we know, particularly in the new kind of networking space, I suppose, for want of a better word, is around that registration and discovery. And then, as a further step from that is the service mesh. And so that's where Consul is kind of building a lot of traction around solving those challenges. And so just from a kind of high level architecture, there's obviously the control plane and the data plane. In the control plane element, you have a leader and followers. That creates your cluster. And that cluster then becomes the control point for agents, so the Consul client or the Consul agent, to be stood up and communicate with that backend or that, sorry, the cluster manager to understand where applications are being found. So as an application will automatically be discovered, so this could be integrated into a Kubernetes pod, for example. So you could use kubeauth to automatically register an application. The console agents feeds that up into the cluster, and now everything knows where everything is. From a data planes perspective, when that and leveraging the service mesh, when the app A wants to talk to app B, it talks to the cluster, finds out where it is, creates a mutual TLS tunnel across those environments, and now you have connectivity. Now, whether this is within a cluster, whether this is across a hybrid scenario, or whether this is even across multi-cloud, this allows you to actually think of really joining the dots around where your applications live. It also opens up an interesting use case that I came across the other day with a customer where they had started to use Consul as a mechanism to migrate services. So because you can discover them and because you can move them anywhere, now you can move parts as you want across those environments. And so that really opens up the ability to then start looking at how you can federate. So in Consul 1.8, there is this automatic federation. So we use a single port now to use across our mesh gateways. We have ingress and egress gateways, so we can actually jump out of the environment and talk to like RDS, so a host that couldn't have a client on it. We can use an egress or ingress gateway to actually talk to that resource. So now outside of your service mesh, you can actually even pull in green screen or agentless resources that you want to be able to leverage and use. And that's a very powerful element, again, in that how can I really take advantage of all of my infrastructure. And that's a fundamental principle that kind of differentiates where Consul has been focused. You know, it's really been thinking around running it anywhere, being able to connect anything to it, whether that be, you know, an on-premise based element, whether it's a cloud-based element, whether it's within a containers, whether it's within even looking to tie into serverless. All of the functions are how do we make sure that your infrastructure can talk across it and provide services within those infrastructures. So, you know, you can integrate Consul into this so that you have automatic certificates across your MTLS, so it can all be mutually generated, and this can all be built and stood up using Terraform. So with our fingers crossed, we'll go over to the demo gods for the final one. So one of the things that we've done here is this is that application that we were talking about. So here you can see we've actually tied 3 data centers together, so the 3 major clouds. In this cloud, we've actually stood up that application, which is our Data Protect. Now, if we wanted to migrate this into one of the other clouds, obviously we've now stood up our Consul cluster within that cloud, and this could be how we're going to pull out from our experimentation cloud into our primary cloud and start actually working with that primary cloud. This demo is actually available and it will be on the slides at the end, so you can actually go and experiment with it. But just from a kind of high level perspective, if we look at good old DNS resolution, this is our Consul service, and it's also indicate, and there we go. So BusyBox had to stand up, and so from this we can see how the console.console service is a snub domain that we create within the Kubernetes environment, and this is then actually resolving back our Consul service. So within our environment, we can actually define an application.service.console, and that will then go to Consul to actually get resolution. Now, where this starts to come into play is this will work across different environments. So here we actually are data center aware. So here we've added that DC AWS, and so now we actually have a DC awareness around pulling out a completely different set of services. So now we can actually say, here's a way that we can pull out those resources from a different environment. Now, I'm going to push my luck and see if we can actually migrate the application. So what we're going to try and do here is deploy Consul, the transit app, across those two other data centers and deploy Vault into those environments. And what we'll do is, at the moment, the application is all running in one component, including that Dynamo backend DB. What we're going to do is we'll keep that database there because obviously, you know, it's too hard to move our database to start with. But our CEO's come in and said, look, we're moving all into AWS. We've got a better deal. The platform's better. I want to use those as our primary regions. Let's do it. So now you're moving that front end, but how do you keep those resources and keep the conversation going? So we're going to deploy some local vaults into those other cloud providers. That vault will be able to then encrypt that data locally and send it back into that single database. So now you not only can you leverage and connect to a single database, you can actually encrypt individual mechanisms that will only be relevant from that cloud provider. So data that is created and used from a data perspective in AWS, even though it's been stored in the backend somewhere else, will only be relevant and visible from that application call in that front end. Whilst this kind of plods through, I'll just hand over to Adrian just to talk about some of the other resources that we have available and some of the shared content that the two organizations have been busily working with.
Yeah, thanks, Dave. So we thought we'd leave you some light reading material to follow up on getting some more detail. The first one we definitely recommend is understanding how you use secure certificate management with Consul. So there's a great blog that's fairly recent that talks about that. Dave showed you how to provision clusters or EKS clusters, which is our Elastic Kubernetes service on AWS. There's a great workshop that you can do or a tutorial that you can follow that's available on the HashiCorp website. And we also talked a bit about how to manage that security and auto unseal. So we've included a link there for you to check these out. Now, if you want to get started with running Vault on AWS, the good news is that you can do that very quickly with an AWS Quick Start. So AWS Quick Starts are gold standard reference architectures that we build together with ISVs, in this case, obviously with HashiCorp, that allows you to build and deploy production grade environments into your AWS account. So what we've done is that we've built an entire Vault environment, which includes all the VPCs across multi-AZ for you to be able to run that scalable environment along with Bastion hosts for accessibility. And again, I talked about some of the integration that we've got with the AWS Identity Access Management Service and Key Management Service and STS. So that's all pre-configured.
Also worth noting, Vault is available on AWS Marketplace, as is Terraform now. So both of those are commercially available via the AWS Marketplace.
Yeah, great points, Dave. And this is really hot off the press. We just announced this just a couple of weeks ago. We have a lot of customers that are running Terraform, but have their infrastructure on AWS. And since AWS announced the Cloud Development Kit, so the Cloud Development Kit is bringing programming constructs to infrastructure as code. One of the biggest asks we got was, can we actually run a common Cloud Development Kit programming constructs across both the Terraform as well as CloudFormation. So we actually announced this just a couple of weeks ago, and there's a great link here to learn more about how that works. So again, being able to build these constructs, across using TypeScript and having your configuration in code like JavaScript or Python, Java, or really any of the other constructs that are supported, makes things a lot easier. Especially when your environment has grown or has been integrated over time. So some great listening that both organizations have been doing to bring that capability to you. So that is now available in preview, and we plan to bring that to full GA later on in the year.
So just while I'll go back, before I just go back into checking on how that demo is doing, let's open it up and see if there are any Q&A in the chat window or in, oh, we're off the chat window. There's my chat window. So we just open it up to see if there's any questions in the chat window. If not, I'll just fly back and, oh no.
Demo gods are not with us today, David.
Demo's goats have died. Nuts. All right. Well, it died. Anyway, I'll figure out why that broke later. Go and cry in the corner. Thank you everybody for listening. Trust me, the demo does work. It's just that because people are watching. The demo is there if you actually want to download it. It's just from my repo. You can use any of the mechanisms, so you can do the full cloud connected and the transit app as standalone, or you can actually do that migration part. With that, I think there doesn't seem to be any questions, so I'll just hand it back to Pete to close out, and we will be spot on time, I think.
We are very good. Thanks, Dave. Yeah, thanks for that presentation and demo, Dave and Adrian. Really interesting. It's good to see so many great solutions we have with Hashicorp and AWS. So folks, as Dave said, that brings us to the end of our session today. We hope you enjoyed it and got a lot out of it. As I mentioned at the top of the call, this session was recorded, and I'll be sending out a link soon to the recording, so you can review and catch up on things you might have missed. And as Dave mentioned as well, there's plenty, and Adrian as well, there's plenty of follow-up material coming your way as well. So in that thank you email that I'll send out, I'll attach a link to the recording and a link to all the follow-up websites you can go to learn more about these great solutions you've just heard of. So thanks again for joining us. Hope to see you on the next webinar, and yeah, bye for now. Thanks again, Adrian and Dave. Great job.
Thanks, Adrian.
Thanks, guys. Thanks, everyone.
Bye.
Thanks, everyone. See ya.